Okay, I'm going to finish the problems that are in this section 6.2. 6.2 was the unit circle and circular functions. So I may have already done this first problem here. Doesn't hurt to do it again. Find the exact values of 3 pi over 2. Negative cosine of 3, but this is sine. Cosine of a positive 3 pi over 2. Tangent of 3 pi over 2. And looking at my unit circle, I want you to realize where we're at. 3 pi over 2. Here is 1 pi over 2, 90 degrees. 2 pi over 2, 180 degrees. 3 pi over 2. If I'm going to do the sine of that angle, the shortcut was find the ordered pair that lines up to that angle. There it is. And remembering that this number is the cosine of that angle. This number is the sine of that angle. So I should be able to write cosine of 3 pi over 2 is 0. Sine of 3 pi over 2 is a negative 1. Tangent of 3 pi over 2 is your y over your x is undefined. Example 2. Use this figure to find the exact values of 7 pi over 4. Well, sine of 7 pi over 4 and cosine of 7 pi over 4. Again, what will I do? I'll find 7 pi over 4. Pi over 4 is in the middle of 90 degrees. There's my 45 degrees, better known as the famous pi over 4. This is one of them. 1 pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. Let's see if I counted right here. 7 pi over 4. This is the ordered pairs. This must be the cosine of that 7 pi over 4. This must be the sine of that 7 pi over 4. So if you have those points on your unit circle, you can find that the cosine of 7 pi over 4 must be square root of 2 over 2. The sine of 7 pi over 4 must be a negative square root of 2 over 2. Let's take a second and pretend I didn't have that picture as detailed with all these ordered pairs and everything there for me. What would I do? I'm glad you asked. I would realize that the pi over 4 is a 45-degree angle. So I could just draw it, realizing that angle's the same as that angle, meaning this side's the same as that side. So that would have meant 1 square root of 2. Pick either angle and realize that the cosine of a pi over 4 is 1 over the square root of 2. And so is the sine, 1 over square root of 2. And if I rationalize those, I get this to be a square root of 2 over 2. I get this one, I should have wrote pi over 4, is also square root of 2 over 2. However, you have to take into account what quadrant am I in. So without looking at that fancy dancy circle over there, I'm going to realize that this is 1, 2, 3, 4, 5, 6, 7. I know I'm in this quadrant. Therefore, I know that this is a 45-degree angle, and this is my right angle. This is also 45, who cares? 1, 1, square root of 2, except this has to be a negative 1 because it's going down. So I'm looking at this angle right here. The cosine of that angle, which is 7 pi over 4, must be the adjacent, which is 1 over the square root of 2, which is square root of 2 over 2. The sine of that 7 pi over 4 must be the opposite, which is a negative 1 over the square root of 2, which gives me the negative square root of 2 over 2, which should match up to my answers that I just had. Let me back and look what I did. The negative was on the sine, and that's the cosine. Use the figure and the definition of the tangent to find the exact value of a negative 5 pi over 3. Oh, he did say use the figure, so I will use the figure. Pi over 3, in my memory, is 60 degrees, because if I divide from here to here, which is pi, into 3 pieces, that would give me a 60, a 120, and a 180. So that's 3 pi over 3. He wants the negative 5. That meant I'm going to go this way. So here's negative 1, negative 2, negative 3, negative 4, negative 5. I know I'll have to be in this quadrant right here, and I'm going to go up to the 60 degrees here. Why do I know I go up to that 60 or 5 pi, or pi over 3? Is because this is also 60 degrees here. And so that's all that's left. Think about what he asked for. Negative 5 pi over 3. If he went all the way to negative 6 pi over 3, that would have been the same thing as negative 2 pi. So 1 more pi over 3 would have taken me all around, going this way, all the way to here. Since he only went 5 of them, then I know I'm stopped right here. So if I'm using that picture, he wants the exact answer of tangent. Here's my ordered pair. Here's my cosine. Here's my sine. Tangent of a negative 5 pi over 3, because that's what I was talking about, is sine over cosine, which is a square root of 3 over 2, over 1/2. That turns into square root of 3 over 2 times 2 over 1. 2's cancel. Square root of 3 is the exact answer. What would I have done if I didn't have that nice, beautiful circle? I'd have just done my own thing here. Realize that if I go all the way to 180 degrees, that's 3 of them. I realize there's 2 more. That would be another 120 degrees. So that has to take me past into quadrant 1. And I know tangent is positive in quadrant 1. Drop my perpendicular. And I realize that that would have been basically a 60-degree reference angle. So when I say tangent of a negative 5 pi over 3, in this case, it's identical to the tangent of just a positive pi over 3. It's the same. Both are in quadrant 1. Both look like that. It's the same answer. So if I was in my calculator, I could have just typed that in, but he wants the exact value. So since my triangle looks like that, 60 degrees, then that must be a 30, and across the street from 30 is a 1. Hypotenuse is a 2, and the other leg must be square root of 3. Tangent of this 60 is opposite over adjacent. Go figure, it's automatically a square root of 3. See that? Same answer I had a second ago. Use reference angles and radian to degree conversion to find the exact value of cosine of 2 pi over 3. He's given me permission to use reference angles. Again, pi over 3 is a 60-degree angle. So there's two of them. That's 120 if you think about it, because 3 of them is 180. So here is the movement, or my angle. He said feel free to use reference angles, so that must be a 60 degrees to get down to the 180. So it's 1 pi over 3, 2 pi over 3. There's my triangle. I'm in quadrant 2, so this value, this is 30. Across from 30 is a 1. Hypotenuse is 2. Other leg, the adjacent, must be the square root of 3. But this opposite must be negative, because I'm in quadrant 2. Cosine of 2 pi over 3 must be, okay, here's the angle. Cosine is adjacent over hypotenuse, negative half. Let's just double check that. 2 pi over 3 in my unit circle that I have up here. 2 pi over 3 right here. 120 degrees. Negative half was the cosine. Sine is square root of 3 over 2. And that is what I have. I hope I don't have to show you how to use every single thing on the calculator, but make sure you are in radian mode. How do I know it's not degrees? There's no degree sign. You have to use degree if you're in degree mode. Make sure your calculator's in radians. And I'm going to just type, I'm going to do all of these. Cosine of 1.85, cosine of 0.5149, cotangent, that will be a little harder. You'll have to type it in on your calculator, is 1 divided by the tangent of 1.3209. Secant, you'll have to type that in as 1 over the cosine of a negative 2.9234. Pure calculator work. Not going to do them for you. Inverse cosine 0.9685. .25166. And since it's in radians, I don't need any unit. I can say it if I want to, or I don't need to, whichever you want. B, find the exact value of the angle marked as S in the interval from pi to 3 pi over 2, and I know the tangent of that angle is 1. So I'm going from pi to 3 pi over 2. Remember what we've done before? 1 pi over 2, 2 pi over 2, 3. That's the interval I'm at. Any angle in there where the arc tangent of 1, what angle will that be? What S is that? So I have to ask myself, how do I get a tangent? Now remember, tangent of theta is always sine of a number over a cosine of a number. So it's a fraction. So when I'm looking at the 1, I'm looking at 1 over 1. Also, tangent on a triangle is opposite over adjacent. What kind of triangle has a 1 over 1 opposite and adjacent? I hope you see that it has to be a 45, 45, 90 triangle. 1, 1, square root of 2. So it has to be some sort of 45-degree angle. S is some sort of 45. And in that interval, I could literally draw one right here. But that's not the interval of my answer. The interval of my answer has to be between pi and 3 pi over 2. So yes, I have a 45 here. I have a 45 here. But that's not the one I want. I have another 45s here, and I have another 45 here. Those are not the ones I want. I want the one that's in here. So when I drop that down, this is my right angle. This is a negative 1, square root of 2. So opposite over adjacent is a negative 1 over negative 1. Negative 1 over negative 1 is 1, which is what I am asking for. So what flavor of pi over 2 or pi over 4 angle 45 that's in this quadrant? Well, this was a 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. The answer has to be is 5 pi over 4. That's where tangent is positive. All students take tangent's positive in that quadrant. Tangent is positive in that quadrant, but that's not in my interval that he wanted. I am not going to do line segments. So I'm not going to do those. Another line segment problem. Linear and angular speed. If you're running from point A to point B, that's considered a linear speed from A to B. Represented as miles per hour, feet per second. Okay, you get the idea? If you're running around a circle, like a circular track, and you're running a 440 meant meters. So if you start running here, You take off running, and you end up back. You ran a 440. If you spread that distance out, there's your 440 meters. And let's say you did 440 meters in a minute. That would have been 440 meters per minute. That's linear speed, even though you were going around the circle. But at that same time, when you're going around the circle, and that's not a circle on a track outside, that's an elliptical. But if your track was circular, and you did that, here's your starting place, and you did your 440 run. It's also, what I can tell you is your angle of movement also, because look what happened. As you were running, the angle opened up, angle opened up, angle opened up, angle opened up, you see? So you also have angular speed. That would be measured in something we would call radians or degrees per minute, since we were doing minutes there. Two formulas we're interested in. Distance divided by time. 440 meters in 1 minute was your linear speed. We call that velocity. It's the distance you traveled. There's my S, and notice it could also measure the arc over time, or the degrees, or the radians in this case, where S is the length of the arc traveled by point P at any time. As point P in the figure moves along the circle, as I just said, point P, that's you running around, the ray OP rotates around the origin. OP is that distance here. And I mentioned how that is changing from here to here. So we call that the ray OP rotates around the origin, because ray OP is a terminal side of the angle. Angle POB. So POB, wherever B is going to be. Oh, POB, there's B right here. Because he said that's my terminal side. That means it doesn't. Where did I see B? Let me erase it so I can see it clearly. Yeah, he's locking it in. He's locking B in. We say the measure of angle changes as P moves along the circle. The measure how fast the angle POB is changing is called the angular speed. And there's our symbol. We call that omega. Omega is the number, how your angle is changing, not the arc, but we're actually literally saying how many radians per time. Theta is a measure of the angle POB at any time t. With earlier formulas in the chapter, theta must be measured in, well, we're doing radians right now. With omega expressed in, I don't know how you're getting that many blanks. Omega is expressed in I still can't figure out why there's 4 blanks. It's the number of radians per, maybe unit of time, maybe. I'm just guessing. Formulas. Well, omega is theta over time. Velocity started out as the distance around that arc per unit of time. I think what he wants me to do is try to connect these two things together. If I solve this for time, time is O theta over omega. If I plug that in over here, I get S over omega over theta, which gives me, if I take the top fraction, divide the bottom, S omega over theta. I'm not sure what he's wanting me. Could also say, these are all true. These are all true. We did have another formula at the beginning. We said S, from a previous lesson was R theta. S is R theta. So velocity could also be R theta over time. And time that I have here can be plugged in now. Would be velocity is R theta over omega, which, to help you out, that's R theta over 1 times the reciprocal omega over theta. The thetas cancel. Velocity can also be R omega. That's your radius of the circle times your angular speed is your velocity. Suppose that point P is on the circle with a radius of 10. Here's point P. And the ray OP is rotating with angular speed. That's omega. Pi over 18 radians per second. So in here, theta's changing. And it was smaller, but it just tells you that every second it's pi over 18, pi over 18, pi over 8, whatever size that is. Find the angle generated by P in 6 seconds. Well, I'm going to use the velocity equals to radius. I'm talking about the radius of a circle. That's very handy. Omega, because he gave me omega. And he actually gave me the radius. So if I'm going to have to find the angle. Time is theta over omega, which we had that on the other page. Let's plug in the stuff that I have. Time was somewhere. Here's time. So 6 seconds was equal to theta, that's what I'm looking for, over omega, which was pi over 18. Pi over 18. Multiply both sides by pi over 18. Theta will be 6 pi over 18. That will give me pi over 3 radians. B, find the distance traveled by P along the circle for 6 seconds. That's the arc length. S equals to R theta. S, my radius was 10, my theta was pi over 3. So it's 10 pi over 3. And what was my units? Centimeters. Find the linear speed of P in centimeters per second. V was S over T. You can back and look at the other slide, and you'll see it was there. S, I just did S, 10 pi over 3, and obviously that was centimeters, just to show you something. Over the time was 6 seconds, right? So the time is 6 seconds. So you got your centimeters per second. There it is, centimeters per second. Let's try to get these numbers to cancel out. 10 pi over 3 times the reciprocal of 6 over 1 is 1 over 6. That's 10 pi centimeters over 18 seconds. That can reduce to 5 pi centimeters in 9 seconds. Or you could just say 5 pi over 9 centimeters per second. Find the angular speed of a pulley and linear speed of a belt, because this pulley is turning. It's going around and around and around. As it goes around, there's teeth inside this pulley that pulls this belt, so the teeth in the belt, and the belt is moving in a linear speed direction. And the pulley obviously has has angular speed going on. Find the angular speed of the pulley. Radians per second. We know that the belt is that has a pulley of 6 centimeters. So this circle is 6 centimeters. And we know it's spinning 80 revolutions per minute. Well, 80 revolutions per minute. Let me clean that up. Omega is 80 revolutions per minute. And 1 revolution, remember, is 2 pi radians. Okay, so I'm going to go 80, that's 80 revolutions times 2 pi per minute. Now, while I'm thinking about it, he wants it in radians per second, so I need to use that dimensional analysis where I multiply by another fraction that cancels out minutes. We've done this several times, so hopefully you see radians per second. 1 minute is 60 seconds. Therefore, the minutes cancel out. So I'm left with 80 times 2 pi times 1 divided by 60, which is 160 pi divided by 60, and which is 80 pi divided by 30, which is 40 pi divided by 15. See, I just keep reducing it by cutting in half. It's the easiest thing to do, till small enough for you to see, oh, I could have gotten another 5 out of there. 8 pi. I'm going to put the word radians. You don't have to. 8 pi radians per 3 seconds. Or 8/3 pi radians per second. Letter B, find the linear speed of the belt in centimeters per second. Well, the linear speed, and we're looking for the speed of the belt, that was R omega, as I recall my formulas. And I already forgot how big the belt was the radius of the pulley. The radius was 6 centimeters. So that would be equals 6 centimeters. Omega, not in the problem because I found it over here. 8 pi over 3 and that was radians per second, and that's what I want. But he wants centimeters. So you start knowing you got the answer right when you see your units coming out the way you want it. So that gives me, well, the 3 goes into 6 twice, so that's 2 times 8, 16 pi. And let's see. 8 pi over 3 was radians per second. Hold on. Why I want to get my radians to disappear. Looks like that's the last problem. Okay, that should be enough to finish up your lesson 2. Adios.